Alright, in this video we're going to do some substitution questions from the textbook. So here's question 1. In question 1 we've got a equals 2, b equals 3 and c equals 5, and we've got to evaluate these expressions using that information. So in each question we're just going to replace the letters with the appropriate numbers. So a plus b becomes 2 plus 3, which is 5. In question b we've got c minus b, which becomes 5 minus 3, which is 2. So far they're pretty easy. C minus A minus B becomes 5 minus 2 minus 3. So going from left to right, we've got 5 minus 2 is 3, and then 3 minus 3 is 0. In question D, we've got C minus A minus B in brackets. So if we replace the C with 5, and then in the brackets we put 2 minus 3, then BODMAS says do the brackets first, so we do the inside the brackets and we end up with 2 minus 3 is negative 1. Now we've got 5 minus negative 1, so a minus and a minus becomes a plus, so it becomes 5 plus 1, which is 6. In E, we've got 7 times A being 2, and then plus 8 times B, which is B is 3, and then we've got minus 11C, where C is 5, so 11 times 5. BODMAS says work out each of these multiplications first. So 7 times 2 is 14, 8 times 3 is 24, and 11 times 5 is 55. So 14 plus 24 is 38, and minus 55 is going to be negative 17. Okay, for the next one we've got A over 2, so that becomes 2 over 2, and we've got B over 3, which becomes 3 over 3, and C over 5 becomes 5 over 5. Notice in each case all I've done is just replace the letter with the number that was given to me at the start. That's all you've got to do, and once you've replaced those, then you can simplify it. Each of these becomes 1 over 1, so 1 plus 1 plus 1 equals 3. Okay, in G we've got ABC, which becomes 2, 3 and 5. This is one helpful way to deal with these substitution questions, is to put each value that you substitute into brackets, and then it becomes a little bit clearer what you have to do with it. This is 2 times 3 times 5, 2 times 3 is 6, 6 times 5 is 30. H, we've got A and B outside the bracket, so that becomes 2 and 3. And then inside the brackets we've got C minus B, which is 5 minus 3. So this bracket 5 minus 3 becomes 2, so we've actually got 2 times 3 times 2, 2 times 3 is 6, times 2 is 12. Okay, let's rub those out so we can fit some more in. Okay, the last few we've got for I, a squared plus b squared minus c squared. So a squared becomes 2 squared, b squared becomes 3 squared, and c squared becomes negative minus 5 squared. So when we evaluate that, this becomes 4, this becomes 9, and this becomes 25. So we've got 4 plus 9 is 13. 13 minus 25 is negative 12. For J we've got c squared plus a squared, so that becomes 5 squared plus 2. So c squared plus a. 25 plus 2 is 27. For K we've got minus a, which is minus 2, times b, which is 3. I'll put that 2 in brackets there, and then times negative c, and c is 5. I could put this negative inside the brackets here too. It wouldn't make any difference to the outcome. So negative 2 times 3 is negative 6, and then negative 6 times negative 5 is 30. And finally, we've got 2.3 times a, which is 2, a is 2, minus 3.2 times b, which is 3. 2.3 times 2 is 4.6, minus 3.2 times 3 is 9.6. 4.6 minus 9.6 equals negative 5. And the answer for, there we go, negative 5. Okay, in question 2 it's pretty similar, but this time we've got two different values we're given. D equals negative 6 and k equals negative 5. So note these are both negative numbers, and that's going to create some more interesting situations when we substitute them in. So in A we've got d plus k. Now d is negative 6. This is where the brackets can really help us out when we've got these negative numbers. D is negative 6 and plus k, which is negative 5. So negative 6 plus negative 5 equals negative 11. In B, we've got d minus k, where d is negative 6, and minus k, which is negative 5. Notice we've got these two negatives here, so that becomes a positive. So it's negative 6 plus 5, which equals negative 1. In C, and a number line can often help with these questions. If you've got negative 6, so this is 0 here, and we're at negative 6, and we've got minus a negative number, minus would normally go in this direction, but because we've got this extra negative, it flips it back around the other way, so we actually end up going 5 in this direction. From negative 6, if you go 5 in the positive direction, you get to negative 1. So a number line can help you to get your head around a lot of these problems. Okay, in C we've got k minus d. K is negative 5 and d is negative 6. So this time those two minuses become a plus. Negative 5 plus 6 is 1, positive 1. In D we've got kd. K is negative 5 and d is negative 6. Negative 5 times negative 6 equals 30, and negative times a negative equals a positive. In E we've got negative d, where d is, so we'll put the minus there, d is negative 6, and inside some brackets we've got k plus 1, where k is negative 5, and we've got plus 1 with it. So each of these brackets, negative times a negative becomes positive 6, and this bracket becomes negative 5 plus 1 is negative 4. So we've got 6 times negative 4, negative times a positive equals a negative 24. Again, it wouldn't have mattered if we'd put the negative inside the brackets here, then we would have had the two negatives together still, it would have still become positive 6. So it doesn't change the outcome there. F, we've got d squared, and d is negative 6, so we've got negative 6 in brackets, and that's being squared. Negative 6 times negative 6, that's what negative 6 squared means. A negative times a negative is a positive. In G, we've got k cubed, so we've got negative 5 in brackets, and it's cubed, so that equals negative 5 times negative 5 times negative 5. 5 times 5 times 5 is 125. A negative times a negative, so we'll put 125 there. A negative times a negative is a positive, but then multiplied by another negative, it's now a positive times a negative, that's a negative. The other way to work it out is if you got a negative number and it's squared, if the power is an even number, then it's always going to come out to be positive. If you've got a negative number and the power is an odd number, it's always going to be negative. So we'll always go to the power of 1, it would be negative, and then squared it's positive, negative, the next one would be positive, negative, positive, negative. So you can always work it out. If it's an even power, the answer is going to be positive. If it's an odd power, the answer is going to be negative. This is for a negative, when you're doing a negative number to a power. For h, we've got k minus 1. K is negative 5, and that's minus 1. That's on top of a fraction, and on the bottom is d, which is negative 6. So on top we've actually got negative 5 minus 1, which equals negative 6, and we've got the same on the bottom. Same thing divided by the same thing equals 1. And for the last one, I, we've got 3 times k, 3 times negative 5, minus 5 times d, which is negative 6. So this becomes negative 15. Excuse my bad writing. And negative 5 times negative 6 becomes positive 30. Negative 15 plus 30 equals 15. Okay, in question 3 we've got same idea again, but this time the things we're going to be substituting in are fractions, so that's going to be a bit more interesting. Okay, in the first one we've got x plus y, so that's going to be 1/3 plus 1/4. Now the thing with these, with adding fractions, is we have to have the same denominator to be able to add them. So we've got to find a way of getting these denominators to be the same without really changing the fractions, and here's how you do that. We've got to find the lowest common multiple of 3 and 4, and that's going to be 12. Okay, so I'm going to change both of these fractions to have 12 as the denominator, because once I've got the same denominator I can add them together. To get this to become 12, I've got to multiply the 3 by 4. Okay, and if I'm multiplying the 3 by 4, I've got to do the same on the top. So 1 times 4 becomes 4. To get 4 to become 12, I've got to multiply it by 3, and I've got to do the same to the top, so that becomes 3 times 1 is 3. Okay, effectively what I've done is multiply each of these by 1. 3 over 3 is 1, and 4 over 4 is 1. So without changing them, when you multiply something by 1, you don't change it. A times 1 still equals A, so you haven't changed it. We're able to get a different denominator, and it looks different, but it's still the same sum, and now I can add them together. 4 plus 3 is 7 over 12. Notice we add the top, but we don't add the bottom. The bottom stays the same. Alright, for b, we've got y minus x, so that's 1 over 4 minus 1 over 3. Well, now we know how to get the denominators the same, so we can straight away change 1 over 4 to 3 over 12, and we can change 1 over 3 to 4 over 12. So we know that 3 over 12 minus 4 over 12, 3 minus 4 is going to be negative 1, and that's going to be over 12. So that's b. In c we've got x times y, so we've got 1/3 times 1/4. Now timesing fractions is a bit easier than adding them, in fact. All we've got to do is do the top times the top and the bottom times the bottom. 1 times 1 is 1, 3 times 4 is 12. Easy. Okay, in d we've got x divided by y, so x is 1/3 and y is 1/4. Another way to think about this is to write it like this: 1/3 divided by 1/4. When you've got a fraction divided by a fraction, you can flip the second fraction upside down and change it to a multiply. And so then we're going to have 4 over 1, 1 over 3 times 4 over 1. And that's easy. Top times top, bottom times bottom. 1 times 4 is 4, 3 times 1 is 3. So that becomes 4 over 3. In the next one we've got x squared times y cubed. So x is 1/3. We'll put that in brackets this time, so it's easy to deal with the power, and then that's multiplied by 1/4 to the power of 3. So let's do each of these separately. 1/3 squared is 1/3 times 1/3. Okay, and then that's multiplied by 1/4 cubed, which is 1/4 times 1/4 times 1/4. Okay, top times top, bottom times bottom, that becomes 1 over 9. And this becomes top times top times top is 1. 4 times 4 is 16. 16 times 4 is 64. So then we've got 1 times 1 and 9 times 64. That becomes 1 over 9 times 64 would be 540 plus 36 is 576. Finally, we've got 9x divided by y squared. So that's going to be 9 times 1 over 3 divided by y squared, which is 1 over 4 squared. Okay, 9 times 1 over 3, that's easy, because 9 is 9 over 1. So we've just got a fraction times a fraction. We do top times top. That's 9 divided by 3. 1 times 3 is 3. And that actually equals 3. So that's on the top, we've got 3. And on the bottom, we've got 1/4 times 1/4, which equals 1 over 16. That's what we've got on the bottom. So this fraction can be rewritten as 3 divided by 1 over 16. And let's rewrite it like this, 3 divided by 1 over 16. Now 3 is the same as 3 over 1. So it's nice when we've got a fraction divided by a fraction, because then we can just change it to times and flip the second one upside down. So that will give us 3 times 16 on top, which is 48, and on the bottom we'll have 1 times 1, which is 1. 48 divided by 1 is just 48. Okay, in question 4 we've got a series of equations with different variables given for each one. So different things we've got to substitute, and we have to calculate one of the variables. So in the first one we've got c equals the square root of a squared, where a is 8, plus b squared, where b is 15. So 8 squared is 64, and 15 squared is 225. 64 plus 225 is 289. So we've got the square root of 289. Let's put that into a calculator. So we've got the square root of 289, which is 17. So c equals 17. In the next one we've got a equals half times b, which is 12, times h, which is 5. 12 times 5 is 60, and 60 times half is 30. So a equals 30. In C we've got the perimeter of a rectangle is given by this equation. Calculate the perimeter of P if L and W equal these two values. Okay, so P equals 2 times L, which is 1.6, plus 2 times W, which is 2.4. So 2 times 1.6 is 3.2, and 2.24 times 2 is 4.8. 3.2 plus 4.8 equals 8. So P equals 8. In this one we've got T equals C over L. We've got to find T. So T equals C is 20.4 and L is 5.1, and I can actually see that this is 4 times that, so it's just going to be that divided by that is 4. In the next one we've got K equals n plus 1, where n is 5, divided by n minus 1, where n is 5 again. So 5 plus 1 divided by 4 minus 1 is 6 over 4, which can be simplified to 3 over 2. You could also write it as 1.5 if you like decimals. Okay, in this one, this is the formula to change Fahrenheit degrees Fahrenheit into degrees Celsius into degrees Fahrenheit. So for changing one temperature to another. Okay, so we've got to put F equals 9 times C, where C is 20, divided by 5 plus 32. 9 times 20 is 180 divided by 5. 180 divided by 5 is 36. And 36 plus 32 equals 68. So that's what F equals. Okay, and the next one, we've got V equals U plus AT, where U equals 16, A equals 5 and T equals 6. So we've got 16 plus, this becomes 30. So V equals 46. In the next one, we've got the area equals pi r squared, where r equals 6. We've got to give it correct to 1 decimal place. So A equals pi times r, which is 6 squared. If we put that into a calculator, we've got pi times 6 squared, which is 113 point to 1 decimal place, it would be 1. That's what A equals. Okay, and the next one, we've got E equals half mv squared. So let's rewrite it as E equals half, and then we've got m is, oh, we've got to calculate m, so we might have to rearrange this equation at the end. Let's just write m in there for the moment. E equals 40, so we can change that to 40, and V equals 4, and that is squared. So 40 equals half times m times 4 squared is 16, so 16 times half is 8, so it's actually 8m. Divide both sides by 8 to get rid of that 8 there, and we've got m equals 5. Finally, we've got r equals the square root of a over pi. Evaluate a to 1 decimal place. So let's try rearranging the formula first this time. So to get rid of that square root, we've got to take the square of both sides. That'll get rid of the square root there. So then we'd end up with r squared equals a over pi, and to get the a on its own, we'd have to multiply both sides by pi, which would give us a equals pi r squared. Okay, and then all we've got to do is substitute in this value for r, so a equals pi 14.1 squared. If we put that into a calculator, pi times 14.1 squared, we get 624.6. Okay, in question 5 we've got 3 different questions and we've just got to evaluate each one. So in the first one we've got PQ, where P is -5 and Q is 4. That's going to equal -20, and so that makes D the correct answer. In this one we've got C squared equals A squared plus B squared. So C squared equals A, which is 6 squared, plus B, which is 8, and it's squared. 6 squared is 36, 8 squared is 64. Add those together and you get 100, and that equals C squared. Now we want to evaluate C, not C squared, so let's get rid of that square with the square root on both sides, so C becomes 10. So that's answer C there. And then in the last one we've got KH squared, where K is 7 and H is 6 and the 6 is squared. 6 squared is 36, and that's multiplied by 7. So that's 210, and 7 times 6 is 42, so that'd be 252. Alright, in question 6 we've got the following. Knowing the length of two sides of a right-angled triangle, the third side can be calculated using Pythagoras' theorem. If the two shorter sides have lengths of 1.5 and 3.6 centimeters, calculate the length of the hypotenuse. So to do this, we've got to know Pythagoras' theorem, which is c squared equals a squared plus b squared. And in this case, we're told that the two shorter sides, which are a and b, have lengths of 1.5 and 3.6. It doesn't matter which one we put into which, it's not going to change the result, they're both going to get squared either way. So we just have to put in 1.5 squared plus 3.6 squared into a calculator and see what we get. So the first one is 1.5 and it's squared, and then we have to add 3.6 and that's also squared, and we get 15.21. 15.21 equals c squared. But we were actually asked to find the length of that side, c, not c squared, so we've got to get c on its own. To get c on its own, we've got to take the square root to get rid of that square and do the same to the other side, which is this side here. So we end up with c equals, let's do the square root of our previous answer, and we get 3.9. So c equals 3.9 centimeters. Okay, in question 7, we've got the volume of a sphere can be calculated using this formula. What is the volume of a sphere with radius 2.5 centimeters? Give your answer correct at 2 decimal places. Alright, so we've got this formula 4 over 3 times pi times r cubed, where r is 2.5 centimeters and it's cubed. Let's put that into a calculator. So we've got 4 over 3, and that's being multiplied by pi, and then that's being multiplied by 2.5 in brackets, and it's being cubed. So to cube something, we put this here in. There we go. And we get 65.45. 65.45, and that's going to be centimeters cubed. Because we had the radius was 2.5 centimeters and it got cubed, the units had to get cubed as well, so it becomes centimeters cubed. Okay, in this question, a rectangular park is 200 by 300 meters. Let's draw a picture of that. 200 meters by 300 meters. If Blake runs along the diagonal of the park, how far will he run? So diagonal would be from there to there. How far will he run if he runs along that diagonal line? Well, this looks like a Pythagoras Theorem problem. We've got a squared, well, we've got a, we've got b, and we need to work out c. And to do that, we use Pythagoras' theorem. C squared equals a squared plus b squared. This is clearly a right angled triangle. So if a equals 200 meters and b equals 300 meters, what does that turn out to be? This is going to be 40,000, and this is going to be, oops, I've got to add a 9 there. This is going to be 90,000. When we add those together, we get 130,000, and then that's equal to c squared, so we're going to take the square root of both sides, and we get 360.54 5, but we need to give our answer to the nearest metre, so we can ignore the decimal places, just round to 361. Okay, in question 9 we've got to determine the value of the following expressions, giving these values for x, y and z, and then comment on whether the closure law for integers holds true for each of the expressions when these values are substituted. Okay, so x plus y becomes 1 plus negative 2, which equals negative 1. So all we're trying to determine is negative 1 an integer like our like our values that we used at the beginning were. 1 and negative 2 are integers. So negative 1 is an integer, so yes, the closure law holds. We can say yes, the closure law holds for this situation. For the next one, we've got y minus z. Y is negative 2 and z is negative 1. That becomes a plus, so we've got minus 2 plus 1, which equals minus 1, and that's an integer, same as the ones at the start were, so closure law holds again. In C we've got y times z. Y is negative 2 and z is negative 1, so negative 1 times negative 2 equals 2, and that's an integer, so it holds again. In D we've got x divided by z, where x is 1 and z is negative 1. So 1 divided by negative 1 equals negative 1, and that's a integer, so closure law has held again. Finally we've got z minus x, where z is negative 1 and x is 1. Negative 1, so that should be a minus in there. Negative 1 minus 1 equals negative 2, which is an integer, so closure law is held again. And finally x is 1 divided by y is negative 2, which equals negative a half, which is not an integer, so the closure law has not held for this last one. Okay, in question 10 we've got some different values for x, y and z, and this time we've got to comment on whether the closure law for natural numbers holds true for each of the expressions. So natural numbers are positive integers. It's got to be an integer and it's got to be positive. So x plus y is 8 plus 2, which equals 10. So both of these are natural numbers, and this is also a natural number. So the closure law has held there. Y minus z becomes 2 minus 6, which equals negative 4. So negative 4 is not a natural number, so the closure law has not held there. In C we've got y times z, which is 2 times 6, that equals 12. So we started with natural numbers, we've ended with 1, the closure law has held. In D we've got x, which is 8, divided by z, which is 6, and so that's become a fraction, which is not an integer. It is positive, but it's not an integer, so the closure law is not held there. And in z we've got 6 minus x, which is 8. 6 minus x is negative 2, not a natural number, so closure law hasn't held. And f, we've got x divided by y, which is 8 divided by 2, that equals 4, so the closure law has actually held for that situation there. Okay, in each of these questions we've got to complete the relationship to illustrate the stated law. So we've got to know what each of these laws are. The associative law says that if we group, if we've got three terms like this and we group them differently, for example we put the brackets around there, for addition the result will be the same, and that's shown by the fact that this it's got equals here. So if we change this around to become a plus 2b plus 4c, then it's not going to change the result. Whether the brackets were, I'll get rid of those brackets that I've drawn in there, whether the brackets were around the first two terms or the last two terms, it doesn't change the fact that these will come out to the same result. and that will hold true for multiplication as well. So if we change this to x times, and then we put in brackets 3y times 5c, it will be exactly the same as this first part here. That's why it's equal. In this case, in the third one, we've got the commutative law, which means if we swap the order of the terms around, for division they won't be equal. So if we put the q first and do divided by 2p, they will not be equal. At least it can't be equal to what this was, whatever it was. For 5d plus q, for the commutative law, it will be true. Because it's positive, the order doesn't matter. So we can swap them around, put the q first and the 5d second. For addition, it will end up to be equal. The identity law says that if we're adding 0 to something, then we can swap it around and it will still be the same thing. It's not going to change what it is. It will be equal. For the inverse law, if we've got multiplication, the inverse of 2x is 1 over 2x, and that's going to be the same even if we reverse the order. So if we put 1 over 2x first and then times it by 2x, in both cases it's going to be 2x divided by 2x, which will equal 1, and both of these will equal 3z. For this one, we've got the associative law, which means changing where the brackets are, but for division it won't work. If we change where the brackets are, it's going to muck it up. It's not going to be equal. So if we do 4x divided by, and then in brackets 3y divided by 5z, then that's not going to equal what it was here when the brackets were in a different place. So you move the brackets for division and it doesn't work anymore. That's what the associative law tells us. And finally, the commutative law, which means swap the order. So if we go to 4y minus 3d, for subtraction that won't work. It can't be the same thing, so they're not going to be equal. Okay, I hope that was helpful. Thanks for watching the video.